Greetings and welcome to the introduction to astronomy. In this week's special topic in astronomy, we are going to talk about an accretion disk and find out what that means. So what is an accretion disk? Well, we could define it as material that is orbiting a star or other body and that is spiraling toward that central object. So what that means is materials swirling around an object as it is pulled in gravitationally. Now we see that in our image here. And in fact, if we take a look at this, we can see that there is material from the star off to the right hand side. Here we have the star and we have some kind of other object here. Could be things like a neutron star or black hole. And if they're close enough together tidally, it can pull material around into it. And that will give what we call the disk of material as it spirals in. So we can see things like compact objects like neutron stars and black holes that will do this. However, you could also get an accretion disk around a star as this planetary system is forming. Now what happens is because of the motion of the gas as it moves in, it doesn't just go straight into, say, the black hole there. It actually comes around with some angular momentum and spins and slowly spirals its way down in toward the central object. And that is where the accretion disk gives off a lot of energy. So for things like a black hole cannot give off energy itself, because once anything crosses the event horizon of a black hole, nothing can escape, and that includes energy. However, as it comes close to there, it can be heated up. So it will heat up and give off energy as the material spirals in. So essentially what you have happening is material being pulled into that central object, whether it be a black hole or a neutron star or any other type of object. It's very much associated with those more unusual objects because of their stronger gravitational fields. And that means they are going to heat things up to higher temperatures. The gravitational force is stronger and they are going to be spiraling around faster, and the heating by friction will lead to higher temperatures. So if it's around a star, it may just be giving off infrared light. If it is around something like a black hole or a neutron star, it could be giving off X-rays. Now we can also have jets of material being expelled from this, and we can see that here. Let's take a look at another image. And we can see that here we see the star labeled off to the left hand side that is orbiting. So here we have the star orbiting, and we have our compact object, maybe a neutron star or black hole. And there's the accretion disk around it, that is as material spirals into it. But as material spirals in this way, material can be beamed out in a very high velocity jet. We have labeled as relativistic jet, and that's because it can be traveling at very high velocities. Relativistic speeds meaning close to the speed of light. And this can be very prominent, especially when you get things like a black hole at the center there that are then emitting a lot. It allows a lot of energy and allows us to detect the energy of that black hole. Now this can be even more extreme when we look at centers of galaxies. Galaxy centers have supermassive black holes that can do this on an even more extreme scale. So let's go ahead and finish up with our summary. And what we've looked at here today is we talked about the accretion disk and how that is the material that is spiraling on to a central object. That material is heated by friction and gives off energy, and it can be heated to millions of degrees, allowing it to give off things like X-rays. This can be involved with stars. It can involve stellar remnants, as we looked at here with neutron stars and black holes, or it can involve supermassive black holes at the centers of distant galaxies. So that concludes this week's special topic in astronomy on accretion disks. We'll be back again next week for another special topic in astronomy. So until then, have a great day, everyone, and I will see you in class.